The future of the planet and well-being of human mankind depend on the concentration of greenhouse gases in the atmosphere. The development of new technologies is crucial for responding to climate change. The construction business accounts for about 40% of all portion of greenhouse gas emissions, and this is all about materials. Imagine if this industry, machinery, could bind CO2 instead of releasing CO2, it would be a giant for the help of turning CO2 emissions around and making them negative, since they are positive today, as we all know. What if, for example, carbon fibers would be made out of biomass like algal oil, and this precursor material would be carbonized to become carbon fiber by focused sunlight directly without using any electricity? This process would definitely be CO2 negative and at most energy efficient. The future of our planet depends on turning things around by 180% and make the industry to become CO2 negative. CO2 negativity can be reached by making carbon fibers precursors out of algal oil, using focused sunlight for simultaneous fiber and electricity production, replacing steel, aluminum, and concrete as being CO2 positive by carbon fibers in combination with mineral material, separation of the two, of the carbon fiber and the mineral material after use, and finally store the carbon in a solid state underground for millions of years. This process is leading over time to CO2 negativity, since we make the material out of CO2. As you all know, carbon fibers are already in use in industries like automotive, aviation. The main material demand, however, is in the building sector. And carbon fibers have not yet fully found their way into this space for two reasons. One is there has not been enough development to make the material usable in construction. But the main drawback, and this is also the reason for this underdevelopment, is the cost of carbon fibers, which is today 2 times more expensive than the equivalent amount of steel. And this is what we are going to change by the production of the fiber by focused sunlight, thus changing the paradigm of using energy. Now, if we want to make it for the 2-degree target, let me say this in a nutshell: what do we need to do? First of all, as we all have discussed for years and years, we have to bet on the reduction of greenhouse gas release by renewables, but that is by far not enough. In addition to that, we need to capture carbon from coal-fired power plants like Mr. Weber from Jupiter Oxygen has been proposing, and we definitely need the transformation of that CO2 into material value, for example, in form of carbon fibers, thus avoiding to press the CO2 underground. And this is finally enabling a long-term storage strategy for the captured and utilized carbon, since the carbon fiber is an utmost stable state of aggregation of carbon. The investment needed in order to cut the carbon fiber price in half is about $300 million for about 10 kilotons per year, with a capacity comparable to that of BMW's Moses Lake fiber production facility in the US. Assuming we replace all steel until 2100, we need 1 gigaton per year of carbon fiber, translating this into 100,000 times of Moses Lake at a cost of $350 billion per year. This would be the cost. And this scenario is based on a solid business model to finance mitigation of climate change at the cost of about 5% of GDP, with a return of investment of 10% per year. And where does this money come from? If you put an incentive of $180 per tax of captured carbon, we are done with half of that already. The rest will come from investors. As you can see, innovation can meet the climate challenges. In case we work on reducing climate risk by turning carbon into an important and positive industrial asset, instead of seeing it a horrible burden and penalty, we are done to make it. I thank you very much.